Hi everyone and welcome to Newegg TV. My name is Paul. Today we have a special guest back in the studio once again. It's Brent Barry. Hey Brent, how's it going? I'm doing well. How are you doing?
Doing very well.
Excellent. And Brent is here because we have a new product launch from AMD. This is the Trinity Launch.
Yes, this is.
And it incorporates a lot of things, as the name Trinity sort of implies. But
right.
We're going to talk about a few things here. We're going to talk about the hardware and the different SKUs that are available. We're going to talk about the features of the Trinity platform, as well as the new FM2 socket. And then we're also going to talk about the performance of Trinity, because the performance is pretty nice.
Yeah, it is. It's really nice.
From what I'm told. So let's start with the hardware. This is actually based on a new CPU microprocessor architecture, formerly known as Bulldozer, now known as Piledriver.
Yeah, they're not exactly the same.
Not exactly, you know? So it's sort of a new version.
Yeah, they're the same family.
Okay.
So Bulldozer was a new type of architecture that was introduced. People would have seen it in the form of our FX processors that released last year, also our Opteron processors that released last year. And the Piledriver architecture is really, it's an iteration of that. Our engineers have taken it apart, they've refined it, they've made it more efficient, higher performing, added in new features, really taken it to a new level.
Okay, and now you originally came, or one of the times you originally came, we were talking about Llano, which was launched, and that was sort of the first APU series that came out from AMD.
Our very first
desktop APU series. Yeah. And that was sort of the combination of CPU and GPU, which we're going to come back to, but this is sort of the next step from Fusion to Trinity. So it does include CPU and GPU, although there's versions without. And then so you get both the Piledriver microprocessor core as well as a 7000 series equivalent graphics card, all tied in on the same chip.
Exactly. Excellent. Yeah, kind of a system on a chip, kind of an idea.
All right.
You get the Piledriver architecture is definitely an upgrade from our Stars cores architecture, which is what we had in Llano.
Okay.
It's kind of going, Stars cores is what we had in our Phenom processors, and Piledriver is what we're going to have in our latest and greatest FX processors.
Okay.
So I mean, this is a big step, generational step.
Excellent.
The graphics, we have a discrete class graphics processor, starting with a 7660D at our A10 A series processors. And this is a discrete class Radeon graphics, high performing Radeon graphics.
And DirectX 11 support, of course. You guys are now in your third generation of support with the DirectX 11 API.
Yeah, we were the first to DirectX 11. We've continued our kind of our leadership in delivering great drivers and great performance in DirectX 11. Lots of big changes. This for us is really it's another one of our Fusion processors. The Trinity platform that we talk about, it's also available in notebooks. This is the first real big desktop launch of those products.
Okay.
Yeah, you might have noticed I mentioned we have an A10 that's out and available now, which is a higher performing version of the A series processor as well.
Previously we went up to A8.
Right, we had an A4, an A6, and an A8.
Okay.
And now, what you should see available at Newegg is an A4, an A8, and an A10.
Okay, so A4 more for the entry level, and then you get more performance as you move up from the A8 and the A10.
Yeah, absolutely.
Okay. All right, so let's get people a little bit more familiar with the various SKUs that are going to be available at launch. There's going to be a lot of them. We have selected a few here to share with people. I know one of the things I'll point out first off is that there are K SKUs, which are unlocked versions of the processors that can't overclock. We're going to come back to overclocking as well. But we have a few examples up here. So
coming out at launch, we'll have a couple of different versions. Like you said, we have an A10, which is available in a black edition or a K series product, and also a standard locked version that's available. The 5800K is the black version. The 5700 is the locked version. Okay. There's also an A8, and the A8 will also come in a 5600K, which will be the unlocked black edition version, and the 5500, which will be the locked non-K, non-black edition version.
So the K moniker at the end of the SKU goes hand in hand with black edition. So black edition is K, and that means it's unlocked and available for overclocking.
Exactly, unlocked. The CPU cores are unlocked, the GPU cores are unlocked, memory is overclockable. It's, you can have at it.
Speaking of memory, what types of memory speeds are supported by these processors?
There's native support for 1866.
Very nice.
Yeah.
And overclock speeds even higher than that?
Yeah, we've overclocked to 2133. Of course, it's not necessarily
supported.
it's
vary
but
based on the processor.
Yeah,
of course,
exactly.
overclock at your own risks and all that good stuff. But
yeah, but native support for 1866. Yeah, we had fun with it. That's the nice thing about an unlocked processor, is being able to see what you can get out of it.
Exactly. All right, so there's some of the SKUs that are available. Next up, let's talk more about the features of these processors, because there are some features which carried over from the original Fusion Llano launch that are now available on these, as well as some new stuff.
Yeah, there's a lot of exciting things on the new versions. I mean, first of all, we talked about the Piledriver architecture, which has been brought in, and that offers a big performance increase. It's an important feature. Also, Radeon graphics that are incorporated are 7000 series Radeon graphics. So 7000 series discrete level graphics that are available. You know, the memory controller has been upgraded, like we said, to an 1866 memory controller, native support for 1866. Also, we have support for Turbo Core, which is our turbo, in frequency enhancing feature, which allows you to, when you're using the processor, if you're not really using all the cores, you're doing something light like shopping on Newegg, then you're not going to have to use all of your processor cores. But as soon as you jump into doing something like playing a higher end game, if you don't need all 4 cores to be running, you can even have 2 of those cores shut off, 2 of those cores boost up. So you can have, for example, at our top-end A10 3800K, the base frequency is a 3.8 gigahertz, but the max boost, which is a native turbo core boost, when you need it, is 4.2 gigahertz.
Right out of the box.
Right out of the box.
That's quite an impressive.
Yeah,
that's quite an impressive boost. So basically, you have that nominal speed. That's the frequency it's going to run at, no matter what. And then it's going to sort of vary based on the use case scenario that what kind of load you're putting on the processor. So it may overclock if it's using less cores, and then it actually might underclock as well if you are actually idling or not actually putting any load on it, and that's going to save energy at the same time. Yeah.
I mean, we've always had kind of the energy efficiency pieces of the processor. Frequency changes, to be more efficient. When you don't need it, pieces of the processor will start shutting down. We get more and more methodical with this, so that pieces of the processor actually shut down now, not just go into a lower state, but they can be pretty much gated off.
Just turns off entirely. Yeah. It's similar to the. Oops, we lost the box. Similar to the zero-core technology and the 7000 series of graphics card, if you have a secondary graphics card that's not being used, it just shuts it off entirely.
Right. Yeah. Those are the kinds of things that can happen. And that's one of the things that makes this next generation CPU APU architecture.
Now, since we're talking about some of the new features that were introduced, you brought along a nice slide of the A-Series Llano Socket FM1 processor next to the A-Series Trinity Socket FM2 processor, and since you know more about processor architecture than I do, can you actually point out to us on these slides what we're looking at?
Yeah, of course. I mean, I think you can see pretty clearly that this is a pretty radical change.
They look quite different.
Yeah, not just the colors, which, of course, we're choosing beautiful images to make it all enhanced and all. But if you look at the Llano processor, when you're looking down in this area, that's where you're looking at the actual x86 cores.
Okay.
And each of those cores, those 4 purple areas, are actually individual x86 cores. Up in the top area is where you actually see the SIMD, or the graphics processor. And one thing you can notice already is how much of this processor, this APU, is dedicated to graphics.
That's a lot of it.
I mean, it's a huge portion of it. When you move over into the new architecture, the 2012 A-Series Trinity for our socket FM2, one thing you'll notice, the Piledriver architecture, which is here, Piledriver, one of the features that was introduced with Bulldozer and is here now with Piledriver, is the idea of these shared resources between these Piledriver modules. So each of these cores are actually sharing things that are great to be shared, because it makes the processor much more efficient and can boost performance. Things like the FPU, the floating point unit, things like that are actually shared between these cores. So they're two pairs that are working together. So one of the reasons, you might in the past AMD's had single cores and dual cores and triple cores and quad cores. With this architecture, you'll see pairs of 2.
Okay.
So you'll see dual cores, you'll see quad cores, in other versions of processors, you'll see even higher core counts.
Oh, so there might be additional cores coming on the Piledriver architecture in the future.
There could be.
Who knows?
It's possible.
We'll leave it at that. So we can see definitely a pretty radical architecture change here just by looking at the pictures. We can also see you got some 3D Mark 11, PC Mark 7 scores listed down there at the bottom. So 37% jump in 3D Mark 11, 25% jump in PC Mark 7. So just a quick example of the jump you get moving from Llano over to Trinity. So with that, actually, it's a good segue to move into talking about the performance of these processors, because obviously we can talk about the features, but the features need to lend themselves to improve performance over time. There's a quick example of it. What sort of performance increases are you seeing just in general going from Llano to Trinity?
Well, being very generic, you can say that the x86 piece of Trinity makes a substantial leap in performance. We're looking at about a 25% increase in performance. That's a pretty big deal.
That's
architecture to architecture.
For the CPU side?
Yeah, the x86, the CPU, traditional CPU side.
Okay.
On the graphics side, we're seeing even a bigger jump. We're seeing about a 50% increase in performance.
Wow.
Going from the 6000 series that we had to this 7000 series architecture has been a huge leap.
And Llano, when it originally launched, really got a lot of positive press just for the graphics component alone. I mean, it was a really big jump up when you compare it to like integrated graphics, that sort of thing. So 50% performance improvement here. And you're showing me a benchmark test that you guys had run with Torchlight.
Yeah.
Actually running 3 monitors Torchlight off of a single one of these processors.
So running an A10 3800K, number one, with all of these APUs, you now have support for Eyefinity, which is pretty big. I mean, if you're running you want a gaming system for a game like Torchlight 2, having Eyefinity is a huge advantage, not just in in playing a competitive game, but also just in the visuals of what you see, the overall interface. Also, the ability to to work across multiple monitors. And the cool thing about Eyefinity is it's one unified visual space. So you're not managing all different monitors. You're able to drag and pull stuff anywhere you want it to very easily. In this example that we're showing, playing Torchlight 2 across 3 monitors at max settings using an APU and still getting 32 frames per second.
Very playable frame rate.
Yeah, one great frame rate. It's probably not the highest end, visual, bring your computers to its needs crying kind of a game, but still, that's visually very impressive.
Yeah, we're not necessarily talking about like Battlefield 3 here or anything like that, but I mean, we're talking about APUs here, which a lot of folks are purchasing because they're low power. They want to build maybe a small system or something like that. It's really not geared as much towards the highest of the high-end gamers, but the fact that you can get that, you can get the performance you get, and if you load up even a game such as Torchlight, there's lots of games out there that are very popular that aren't necessarily really hard on the graphics. You got like Torchlight, you got World of Warcraft, games like that, you're going to be able to play with this type of processor, and you don't even need a discrete graphics card.
Yeah, exactly. Don't need to get the discrete graphics card. You get great performance. It's not that expensive. It's a great way to start. And also, as far as upgradability, one important feature around the FM2 architecture, whereas we did make a change from FM1 to an FM2, which means you got to get a new motherboard to support this processor. But the change to FM2, looking forward, we look to maintain the uniformity in that socket infrastructure. So you can have, you can make upgrades throughout the years.
Okay. So the plan for AMD is to support or continue designing processors on the FM2 socket for at least the next 2 years?
For the next couple of years. Okay. Yeah, our plan is, a real commitment from the leader on our desktop team to make sure that we maintain some socket stability.
Okay.
And also in gaming and performance, I mean, we still have dual graphics available.
That is actually, I thought you were leading towards that, and I was going to point that out next, that if you do want to purchase a discrete graphics card, that you do have the capability to use dual graphics.
Right.
So you'll find on the side of a lot of these boxes, there's some recommendations for different types of GPUs that would pair up well. We apologize, there's no actual processor in this box, but there you can see it down at the bottom. So HD 6000 series video cards that you can line up with these and support dual graphics. So if you already have one of those cards, if you want to purchase one, then you can get increased performance by pairing it with the iGPU in the Trinity processor. And then you can also, of course, just purchase a separate discrete graphics card if you don't want to use dual graphics. So if you go with a higher end, like 7000 series card, like 7770 or 7870, you can use that along with it, and then just simply use the discrete graphics by itself.
Yeah, absolutely. Yeah, you have both options, and you get a dual graphics will give you a very decent performance boost. It works similarly to Crossfire does in the pure discrete world. It's game based. Sometimes you'll see an amazing leap in performance. Sometimes you'll see a decent leap in performance. But also you always do have the option. I mean, this is a great. The x86 cores in this processor and this APU are wonderful as well. So pairing that with a higher end discrete card, if that's the upgrade you want to make, is a great way to go as well.
And it's a great way to introduce yourself if you've never built a PC before. For example, you want to get into PC gaming, but you don't necessarily have the money for your base platform CPU as well as a discrete graphics card. You can go with something like this, game with it right off the bat, and then save up for an improved graphics card, add that on in the future.
Yeah. Absolutely. And on the Black Edition, on the K series, being able to keep that upgradability going is even easier because of the overclock ability. And
now that you mention it, let's talk about overclock ability. I understand you guys have been working with overclocking, doing some tests. Of course, these might reference some exotic cooling, for example, but we do have some performance numbers here that Brent has brought along. And when you talk about overclocking, usually you want to talk about a percentage increase that you can get, whether you talk about a benchmark that you're running and the performance increase there, or just a frequency increase. So I see that you have gotten one of these CPUs up to 6.5 gigahertz.
Yeah, we're using liquid nitrogen.
That sounds dangerous.
Yeah, well, yeah.
Not with LN2 though.
Yeah, LN2 is not that dangerous. You don't want to swim in it.
Of course.
This is using liquid nitrogen. Any overclocker knows that you're not going to do this for long periods of time unless you have a 3,000 square foot house that you can dedicate mostly to tanks of liquid nitrogen.
Like I have at home.
Yeah, of course, really.
Oh, not really.
But being able to take one of these processors up to 6.5 gigahertz in an LN2 test is pretty impressive. With having a base frequency of 3.8, just within our own TDP or thermal dynamic power range, the processor will overclock itself already to 4.2. There's a lot of headroom. Even if you're just using an exotic air cooler or water cooling or other kinds of liquids, you can get a really impressive performance boost out of this processor.
Excellent.
And not only the x86 cores, you can overclock the graphics cores as well.
I see that the GPU you've got up to 1.05 gigahertz.
Yeah, so went above 1 gigahertz. And again, exotic cooling, but the ability to take the CPU core up and the graphics core up means that you can keep getting more and more life out of this APU.
So you can always overclock in the future if you want more performance.
Exactly. Yeah, if you just want a processor that you can get more performance for gaming. You can match it up with a discrete level processor. If 1866 memory is not enough for you, you can also overclock to faster memory speeds. It gives you the ability to make those choices. And
but we're talking about overclocking, but I really like just the starting off point, like you said, having a turbo core, be able to boost that up over 4 gigahertz right out of the box is pretty impressive. And then, of course, if you want to go with the aftermarket cooling or something like that, you can get even better numbers.
Right.
Now, before we close, I know there's one other aspect of these processors that you wanted to point out, and that is the actual application hardware acceleration, which not everyone's familiar with, but that is actually using, for instance, the iGPU in these units to perform hardware acceleration, for instance, with stuff like OpenCL.
Yeah.
Do you want to tell us a little bit more about that?
Yeah, absolutely. I mean, this is key to the story about these APUs. We didn't come together with ATI just to bring x86 and graphics processors together to have a better gaming experience. That's one amazing benefit of this. But really, it's about the future of computing. That today, with things like OpenCL and Direct Compute from Microsoft, if you see the kind of the adoption curve that's happened over the past couple of years of software developers who are actually changing their software so that it is accelerated by the graphics processing unit, it's pretty amazing. And it's not just for the user interface or to make whiz-bang graphics. It's all about the idea of parallel processing, being able to crunch massive amounts of data much more quickly on the GPU than you ever could on an x86 core. So things like Creative Suite 6 is graphics hardware accelerated, and almost all, I believe, all the browsers these days are hardware accelerated. We went from our initial launches into the world of Fusion, where we had tens of examples of software that were accelerated. Last year we were talking about hundreds. Now we're talking 200-300s of pieces of software. It's gotten to the point now where we really can't track everything that's being accelerated. There's a website that you can look at AMD. It's called AMD Cool Apps, which is a great place to go, and you can see all these examples of software that's accelerated for the GPU. And of course, it works on the APU as well as on our discrete GPUs.
All right. So if you guys want to check out more, because I know there's probably a lot of people out there who have no idea what we're talking about, it's okay. It takes a little bit of learning and getting used to, but massively parallel GPU compute applications. Some examples of that over on the AMD website, so you guys can check it out. And of course, you can take advantage of it with these new APUs as well as future AMD products, which we'll talk about sometime in the future.
Sometime.
All right. Yeah. So I think that's going to wrap it up for this video, though. I wanted to say a big thank you to Brent Barry for stopping by today and telling us more about the Trinity APU.
Yeah, thanks for having us and thanks for being here.
All right. If you guys want to see more, you can check out our Newegg YouTube channel. That's youtube.com/Newegg for more on AMD stuff in general, whether you want to look at their processors, you want to look at their graphics cards, AMD.com. You can head over there and you can route yourself in the right direction by clicking on things that make sense for the stuff you want to find out about. Thanks for watching today's video, everyone, and we'll see you all next time on Newegg TV.